Hi, fifth graders. Today we are starting our geometry unit, and we are going to start with 3D shapes. So we are going to be looking this week at three-dimensional figures like cubes, prisms, and pyramids. And we're going to describe and classify them by the number of edges, bases, and vertices, as well as the types of faces. So right now, go ahead and get out your math notebook and make sure that you put 322, today's date, and solid figures prisms, because today we are going to focus on prisms. Okay, before we start and before you start taking your notes, we're just going to go over a few of our vocabulary words. So a face is a flat surface on a solid figure. So on this cube, you can see I've colored in one of the faces. It could be any face on the cube. So here I have a cube. And on this cube, a face would be any of these flat squares, would be a face of this shape. Any of the sides, the flat surface on the outside. A base is a special face on a solid figure. So what you can see on this pyramid is that I have highlighted the bottom of this pyramid because it is the base of this pyramid. The reason we call it the base here is because this base tells us what type of pyramid this is. Because it is a square, it tells us this is a square pyramid. I have one of those too. So here I have a pyramid. All of these sides are triangles, but the bottom of my pyramid is a square, and that tells me this is a square pyramid. This is the base because it tells me what type of shape this is. We can have bases and prisms too, like we're going to learn about today. So here's an example. This one has hexagons as two bases. This is a prism. It has two shapes connected by rectangles. And the bases are hexagons. The reason we know they're the bases is because they tell us what type of prism this is. It's a hexagonal prism because it's got a hexagon on one end and a hexagon on the other, connected by rectangles. So we also have edges and vertices. So first, the edges. An edge is a line segment where two faces of a solid figure meet. So in this, you can see I highlighted the edges here in pink. On our cube, you can see edges where you can see the two faces meet. Any place where two of these faces meet is an edge. A vertex is the singular, meaning one. The plural of vertex is vertices. So a vertex is a point where three or more of these edges meet. So you can see on this cube, I put little green dots at all of our vertices. Right here in our cube, you can see them too. Wherever the 1, 2, 3 edges meet is a vertex. So you can see the vertices on our cube. And then today, we're going to use faces, bases, edges, and vertices to help us define different prisms. A prism is a solid figure with two parallel congruent bases joined by rectangular faces. So, in this example right here, this is a rectangular prism. It's got two rectangles as bases, and they are connected by rectangles. This parallel congruent, what that means is that our two bases are the exact same size and shape. So here's an example of a different type of prism. This is a triangular prism. Our two bases are triangles. There's a triangle on one side and a triangle on the other. They are congruent because they are the exact same size and shape, and they are parallel. And they are connected by rectangles. So this is a prism. Two bases that are the exact same size and shape, congruent, and they are connected by rectangles. So now you should have this chart, and this chart is going to go in your notebook. We are going to use this chart to classify prisms. So the very first prism I see here, I'm going to use the bases to help me classify. I see a triangle here, and it's connected by rectangles. That tells me it's a prism. Because I see the two triangles, I see that the bases are a triangle, which has three sides. I know this is a triangular prism. So you should be writing triangular prism right here on your chart. We are going to use that triangle and the three sides to help us figure out how many faces, vertices, and edges. Because it is a triangle, the two bases are triangles. When we're trying to figure out the number of faces, we know we're going to have our two bases, our two triangles, and they have to be connected by rectangles. Well, the fact that there are 3 sides to a triangle tells me how many rectangles we need too. So right here, I have my triangular prism. If I unfold this, you're going to see that we have our 2 triangles, and that in order to make this a 3D shape, to fold it up like this, we had to use 1, 2, 3 rectangles. The reason we had to use 3 is because a triangle has 3 sides. You can see that right here. There's a net, a picture of it as well. This is called a net when you unfold it, all of the shapes that you put together. So when we want to know the number of faces, we look at, well, what's the shape of the base? It's triangles. And triangles have 3 sides. So we say, well, we know we need 3 rectangles because our triangle has 3 sides plus our 2 bases. So a triangular prism has 5 faces. We use that triangle again for our vertices. So we say a triangle has 3 corners, 1, 2, 3. There's going to be 3 on one end and 1, 2, 3 on the other. 1, 2, 3, 1, 2, 3. So to find the number of vertices, we take the number of sides of the shape of our base and we multiply it by 2. There are 6 vertices in a triangular prism. We use that triangle and the number 3 again for the number of edges. So because a triangle has 3 sides, we know there are going to be 3 edges around the one triangular base, 3 edges around the other triangular base, and 3 edges that are on the rectangles connecting our 2 bases. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So what we're doing is we're taking the number of sides of our base shape, 3, and we're multiplying it by 3. 3 on the 2 bases and 3 around the middle. 3 times 3 is 9. A triangular prism has 9 edges. So make sure you have everything in the chart written down, including the equations up here that tell you the number of faces, vertices, and edges. And then we're going to move on to our next shape. So this is a rectangular prism. I know it's a rectangular prism because when I look at my bases, I can see that the base shape is a rectangle. Everything on here is a rectangle. Our rectangle has 4 sides. I am going to use that to help me figure out the number of faces, vertices, and edges. This is a rectangular prism. Make sure you're writing that right here in your chart. Here's the net of our rectangular prism. If we unfolded it, this is what it would look like. Now, if I unfolded it, I could go count each one of these rectangles to help me know, or I could just use the 4 right here to help me. Since there are 4 sides to a rectangle, I know I'm going to need 4 rectangles around the middle connecting those 2 rectangles. So 4 rectangles connecting our 2 bases means that a rectangular prism has 6 faces. Vertices, again, I use that 4. Because a rectangle has 4 corners, I know I'll have 4 around one base plus 4 around another base, which is the same as saying 4 times 2. So there are 8 vertices. Same thing with edges. 4 around one base, 4 around the other base, and then 4 on the rectangles connecting them. So 4 times 3 is 12 edges. Make sure you have all of these written in your chart. Then we have our pentagonal prism. A pentagonal prism, I know is a pentagonal prism because my bases have 1, 2, 3, 4, 5 sides. This is a pentagon, this is a pentagon, and it's connected by rectangles. So it's a pentagonal prism. A pentagon has 5 sides. If I unfolded it, this is what the net would look like. So again, because a pentagon has 5 sides, I'm going to have 5 rectangles connecting my 2 bases. 5 plus 2 is 7 total faces. Again, we use that 5 for our number of vertices. Because a pentagon has 5 corners, there are going to be 5 vertices at one base and 5 vertices at another base. 5 times 2 is 10 vertices. Again, with edges, because a pentagon has 5 sides, there are 5 vertices on one end. Sorry, edges. 5 edges at one base, 5 edges at the opposite base, and then 5 edges that connect the rectangles around the middle. 5 times 3 is 15 vertices. Okay, we're going to do one more. So when I look at this one, oh, sorry, 2 more. We have 2 more. When I look at this one, I see 1, 2, 3, 4, 5, 6. This is a hexagon. So this is a hexagonal prism. A hexagon has 6 sides, so that tells me I'm going to have 6 rectangles connecting my 2 bases. 6 plus 2 is 8. 8 faces, and I have one of those right here. 1, 2, and then 6 rectangles that connect them. The number of vertices, again, is going to be based on that 6. There are 6 corners, 6 vertices at one base, and 6 vertices at the opposite base. 6 times 2 is 12 vertices. And then we do our number of edges. Again, we use the 6 because it's a hexagonal prism, so those bases are super important. 1, 2, 3, 4, 5, 6 around one base, 6 around the other base, and 6 on the rectangles that connect the 2 bases. 6 times 3 is 18 edges. Make sure you have all of this, including the name of the prism, in your chart. And we have our last one is the octagonal prism, okay? The octagonal prism is called octagonal because it has an octagon as your base. An octagon has 8 sides. 1, 2, 3, 4, 5, 6, 7, 8. Make sure you write that down. And then again, we're using that to figure out our number of faces, vertices, and edges. So we are going to have 8 rectangles, 1, 2, 3, 4, 5, 6, 7, 8, that connect our 2 octagon bases. 8 plus 2 is 10 total faces. Again, we use the 8 for our number of vertices. 8 on one end and 8 on the opposite end. 8 times 2 is 16 vertices. Edges, again, we use the 8. 8 on one end, 8 on the opposite end, and 8 on the rectangles that go around the middle. 8 times 3 is 24 edges. Make sure that you have this entire table filled out. The name of the prism, the operation that helped you figure out the number of faces, vertices, and edges, and then the actual number of faces, vertices, and edges for each of the prisms that we went over. So now it's going to be your job to find these things and to name the shapes on your slides. So I'm going to show you how to do this first one, so it'll be really easy for you when you get to yours, okay? The directions say first, name the solid by looking at the shape of the bases and the shapes of the rest of the faces. When I look at this one, every single side is a square. That means this is a special rectangular prism. This is a cube. So I would type that in right here. Then it says count the number of faces and put it in the table. So I could do the formula that I showed you in the video where I say, well, a square has 4 sides, so I would need 4 squares connecting 2 squares. So there are 6. You can also look at the picture and count. 6 faces. Then it says highlight each edge of the shape by dragging the pink lines to cover each edge and then put the number of edges in the table. Here's what that looks like. I can see this is a vertical edge, so I know it's got to go where I see vertical edges. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. I shouldn't have started counting differently, but I did. So I had 8 plus 4, and that's going to give me 12 edges. And then the number of vertices. So I'm going to carry, this says put a star on each vertex in the shape and then put the number of the vertices. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 vertices. So you're going to do this one as well, and then you're going to do the rest of these shapes in the exact same way. You're going to name the type of prism. You're going to put the edges on in pink and then do the number of edges. You're going to put the number of faces, and you're going to use the stars and then figure out the number of vertices. Then you have matching, and to do your matching, you're going to use the line tool to match the correct name of the prism to its shape. So for example, this one says rectangular prism. I would look over here and say, this one has rectangle bases, so this is a rectangular prism, and I would draw a line connecting those two. Then when I want to do a new one, I come back up here and I do my next one. Okay? Then you have a couple of questions where you have to name the figure by dragging the circle to your answer, or name it by saying what shape, what 3D shape would you use making these flat figures? What would be the name of the prism here? And then you submit your slides.